All right, good morning everybody. It's time now for another networking video. Today we're going to do some packet tracer builds, but these of course, as you know, will be very similar or the same as you would do on an actual switch or router because they have the same iOS. Special shout out to Garrett Arcaraci, the professor in charge of the 244 class and the 244 class itself. These are for you. Alright, so the first thing that we're going to notice is that we have our devices down here in the bottom, and the reason I'm doing the shout out is because there were a couple of questions that came up, and Professor Arcaraci pointed out a couple of very good things to me. So I want to make sure that we pay attention to not only the kind of device that we're picking, but the model. The one that I will almost always choose from the routers is the 2811. It's got a couple of interfaces, and it is a pretty much straight up router. Now when I'm dealing with switches, I will almost always pick a 2960 like that. Now what we're going to do is we're going to do a couple of example builds here, and then we'll just convert them. So the other thing that I'll point out here is that we've got a couple of other kinds of switches here. Now generally speaking, there are two kinds of switches. There are your standard straightforward layer 2 switch, you know, VLANs and MAC address forwarding and all of that. And then there's the multi-layer switches. And usually when I'm going to play with a multi-layer switch, I'll pick one of these guys here. And one of the big differences between a multi-layer switch and a standard layer 2 switch is it has greater knowledge of the topology. But even with that said, a lot of switches have the ability to do IP routing, which we'll fool around with here later on. And that's really one of the key capabilities that we want to think about as we go forward. Okay, so let's get some cabling going. Ooh. So I am going to connect. We'll go port 1 to F01. I tend to, do stuff like this. Now some of the chassis types on packet tracer are a little dated. So we don't see a lot of gig interfaces. In this case, we've got fast Ethernet. And so that's how I tend to start. So I like to put my F0/0s on the left and F0/1 on the right. And that way I just always know where they are. And we'll do our connections like so. And then we'll add a couple of PCs, like this here. Alright, now the switch interfaces will come up quickly because they are on automatically, but you can see that the router interfaces are not up and running. And I am just going to create really straightforward network. We're going to do some really simple networking here. We'll do the one net, and that should be fine. And then we'll do our gateway. 254. Okay, and let's see, we'll just make note of who we are here. /8 for our CIDR notation. This will be 2.0.0.1/8. Okay, and 2.0.0.253. Now we'll explain why we're using. I like to use high in the range numbers, and I'll explain why I'm not using 254 here in a second. But that's, well, might as well do it now. I'm going to add more routers, and so I'm going to need that interface address in a little bit. So this is 1.0.0.254. And this one will be 2.0.0.253. Now the minute I give these routers these IP addresses, that means the default gateways are going to be, the same addresses here, because this PC is going to be communicating with this particular interface here. Well, let's go to our router. We're going to go to the CLI. We want to no to the initial configuration dialog, and it looks like we're ready to go. So we'll do config T, and I'll go to int f0/1, give it an IP address, 1.0.0.254 and 255.0.0.0. Now we've also got a no shut the interfaces, and we'll see as soon as we do this, this link will come up. There we go. So it's starting to come up. Why is this one orange? Well, this switch is doing spanning tree discovery. And so in 30 seconds that'll change. But while we're waiting, we'll go to F0/1. And the IP address here is 253. And of course, no shut. Okay. Now, I suppose what we can also do is, well, we've got the router here. Take a look at the routing table. And the routing table is instructive for a couple of reasons. One is it tells me not only what the networks are that I'm using, but the name of the interface to which this network is directly connected. Later on in the video, that'll become important to us. But these are really, really handy to know, to understand, or to learn how to understand. Now we've got the link here itself. Take a look at the mask right there. It's 32. Why? Because this is the IP address. So this mask refers to the entire IP address rather than just the 2 network or the 1 network. All right, let's see if we can ping. So I'm going to go to my command prompt, and first I'll try to ping my gateway. That works pretty well. Let's go for broke. I'm going to try and get to the other side. Like that. Now, this first delay is going to be the delay for the ARP request on this side. Whoops. And there it is. There it's successful. So what happened here is I pinged, I got it to the router, and the router said, where are you going? And then he said, oh, you're looking for 2.0.0.1. Let me ARP for that so I can build a frame. And so that first one often times out when the ARP tables aren't updated. Once they're updated on the router, that's successful. Okay. So that's the first topology, really, really basic, pretty standard. We'll use this all the time in networking. The next thing we're going to do is see if we can collapse this and get rid of some of the devices. So what I'm going to do is I'm going to delete this guy right here. So we'll get rid of that, bing, and we'll get rid of this. Yes, we do. And the reason that we're going to get rid of this is because we're going to move this over. We're going to create some VLANs. So we want some VLANs here. And so what I'll do now is we'll go ahead and connect this PC to the switch. Now I'm gonna jump a couple of ports here, just so that I can, sort of remember where all of my nodes are. So I'm going to use port 8 here, and I'm going to reconnect the switch, and I'm going to use port 7. So what I'm going to do is I'm going to say, well, I'm going to say VLAN, and I'm going to tie it back to my networks. It's a good engineering practice. But I use VLAN 1, it's kind of tricky, so I'm going to use VLAN 11, and that'll be ports F0/1, whoops, to 6. And I'll use VLAN 22, and that'll be F0/7 to 12. So that explains why I used the ports that I did. Now, the router and the host have no idea that VLANs are happening here. But if I try that same ping, well, the question is, will it work or will it not? Well, right now, everybody's in the same VLAN. Everybody's in VLAN 1. So theoretically, this ought to work just fine as soon as everybody figures out where everybody is on layer 2. So we'll see. There we go. So it works, right? But we haven't done the thing that we wanted to. We haven't created the VLANs here. All we did was put everybody in the same switch. Now that means that if I was a bad guy and I was watching right here, I would be able to capture some of the traffic. So what we do very, very often is we create the VLANs. And we can take a look at the VLANs by default, then we can see that all of the ports are in VLAN 1, and that's why that last ping worked. So what I'm going to do is we're going to start creating our VLANs, and the way that you do that is just by assigning ports to a VLAN. So first we'll go to, and we can see the names of our ports here. So first we'll go to, I'll show you two ways to do this. Int f0/1, and I'm going to say switch port access VLAN 11. Okay, so that is one way to do a VLAN assignment. And if I take a look at VLANs here, I can now see that VLAN 11 exists, and I've got one port in there. Whoops. Let's do the same thing with one of our other ports, f0/7, and we will say switch port access VLAN 22. Take a look at our VLANs, and now we've got one in each. Well, let's see if our ping works now. And it shouldn't, because we created all kinds of VLAN boundaries, plus we got a port coming up and down here. But even when this port is alive, it won't work. And we'll verify that here in a second. There we go. So now the port is up. Let's try it again. And it still doesn't work. So the reason it doesn't work is because I put this PC in VLAN 11, but its default gateway is not in VLAN 11. I put this default gateway in VLAN 22, but this one's not in VLAN 22. So let's fix that. And I'm going to fix that using the interface range command. And this is the other way to put lots of ports into a particular VLAN. So I'm going to say interface range. Whoa, there we go. And the ones that I have left, f0/2 to 6. And I will say, oh, there's 2211. So there we go. And now I will do the same thing with 8 through 12, I think I was going to do. There we go. We'll do a show VLAN, and we can see that I put 6 ports in each one. All right. There we go. So as soon as the spanning tree discovery is done, we'll give this a test, and we'll see if that works. And theoretically it should, because everybody's in the same, or in the proper VLANs right now. And we're waiting. While we're waiting, I suppose we can ping my gateway to make sure that I did that part right. 254. There we go. All right, let's go over broke. We'll go all the way across. Look at that. It works now. So there we go. So what we did, we got rid of one of the switches and we created VLANs. And the VLANs, of course, behave just like a separate switch, with each VLAN being married to a particular IP-based network, and the associated hosts are addressed in that network if they live in that particular VLAN. All right, let's take a look at one more thing. What if I wanted to get rid of this router? Well, this switch may or may not allow me to do that. So let's see if I can do that on this switch. And the way that I would get rid of the router is I want to turn the switch into a router. So can I do this? And it says, no, you really can't do that. So this is where we need one of these other switches. So let's go down here, and we will try the 3560. So this says right on it that it's a multi-layer switch. And so what I'm going to do is I'm going to replace this switch, or put this here in place of the other one. But let's first make sure that we got the right one. And we'll go to the CLI, and we'll say no here. And what I'm going to do is do IP routing. There we go. Now there are a lot of switches that have this capability. And now in Packet Tracer, it is a 3560, but you might be using a 2900 series switch or something like that. But the key as to whether or not it's multi-layer, one of them is whether or not you can do the IP routing command. Now the other thing that I'm going to do is go ahead and recreate the VLANs that I have over here. Now before we do that, let's take a look at what we have by default. Whoops. And we see we've got VLAN 1. So again, everybody is in VLAN 1. We've got a couple of gig ports that we could use if we wanted to. I'm not going to worry about those. You know what? Why not? Why don't we go ahead and we'll use those we'll put everybody in the VLANs, and then we'll put the router on the gig ports. We can do that. So I'm going to say config T, and I'm going to say interface range F0/0 to 6, switch port access VLAN 11, and then I'm going to say 7 to 12 and VLAN 22. But I'm also going to say int G0/1, and we'll put that in 11, and G0/2, and we'll put that in 22. Now, I would do that if those were uplinks. So I'm just putting that in this video because they're used in the exact same way. They're just faster ports. We're not actually going to use them right now. As I said, we're going to turn this into our router. Now, we already made it into a router, sort of, by using the IP routing command. But what is it routing between? It doesn't understand the IP networks at this point. So the way that you change that is you got to give it a set of IP addresses. Now, I'm going to replace all of this with this switch here, which means that this switch will have the same IP addresses that the router does. So I'm going to say int VLAN 11. Whoops, that's not going to work. Okay. Now this is an important, right? If you don't see that, you want to make sure that you do a no shut. And we'll do an IP address, and we'll do 1.0, whoops, 0.254 and 255.0.0.0. And so if I didn't see that, I would do the same way, right? I would do a no shut. And we'll go to 22 now. And we will give it the IP address assigned to the other router interface, 253, like that. Okay? So now we can start taking a look at routing tables. Now sometimes routing tables don't come up unless they've got nodes in them, but we can take a look and use the same commands that I would use on a router now. So right now we don't actually have anybody in these particular VLANs. So let's do this. I am going to, oops, let's delete switch 0, and we'll leave the router on the board here. But what I'm going to do is connect. Now I got to make sure I do the right VLANs, right? So we want to connect to ports that are in the VLAN. Just for fun, we'll use gig 0 or gig 0/1, and we use 0/2. Now we just upgraded these nodes. We're not going anywhere, but we'll see how this works here in a second. So the VLANs are the same. The difference is that now the VLANs equal my default gateway. So they have the same IP addresses as the router. But the hosts have no idea that they lost their router. They just think that life goes on normally. So let's see if this works. We'll have the same thing. Now the switch will have to update its ARP tables. So this switch is now acting like a router. So now it works on IP protocols in the same way. So we've got ARPing going on. There we have it. There's our successful connection. Now let's take a look at our routing table. Take a look at the change here. Still the directly connected networks, but look here, it says VLAN 11 and VLAN 22. How about that? There we go. So that is a significant difference. And take a look at the size of our topology. We went from 3 devices down to 1. Well, there you go. So that is some basic routing strategies, basic device strategies that you can use for small topologies. Now, it's very common to see very, very large chassis, 3, 4, 5, 6 blades, and having a routing module in them and doing routing in just this exact same way. Well, I just realized we're getting on towards 20 minutes, so I think that'll do it for this video. We'll come back and expand this particular topology with the next video. But until then, hey, I hope your multi-layer switches are doing what they're supposed to and helping those packets get to those destinations.